Hi, this is Mr. Manley. In this video I'm going to do a graph of cotangent, and we'll start off here by setting up the table of values, which we always do with all trigonometric functions, with 5 points. And we're going to start off with an initial point, which we will find by setting the argument equal to 0. And this is how you find the argument or the initial point for any of the trigonometric graphs except for tangent, which uses negative pi over 2. For all the others, we're going to set this argument, the value that we're taking the trig function of, and we're going to set that equal to 0, and then solve for theta, and that gives us our initial point, in this case pi over 6. Next, we want to find the step, and the step is equal to the period of the function divided by 4, and the period of the function is equal to pi over the leading coefficient of the argument. So up here with this argument, the leading coefficient is 1. It's 1 theta, right? So that's what we mean by the leading coefficient. So in this case, the period is pi, and then therefore our step is pi, because that's the period, divided by 4. And what that means is that we are going to add pi over 4 to the initial point until we get 5 points. And looking at these and seeing that I want to add pi over 4 to pi over 6, I'm seeing that I want to get some kind of common denominator here so that this will be a little bit more convenient. So it looks like the common denominator to do is 12. So if I multiply by 3 over 3, I'll get 3 pi over 12. And that's equivalent to pi over 4. And then up here, I'm going to do that with the pi over 6. So let's erase that and say we want to write pi over 6, an equivalent value, but with a denominator of 12. So let's call that 2 pi over 12. And then that is equivalent to pi over 6. And then let's add our 3 pi over 12. So 2 pi plus 3 pi is 5 pi over 12. And then add 3, and we get 8 pi over 12 plus 3 is 11 pi over 12 plus 3 is 14 pi over 12. And those are our 5 values of x. Okay? So the next step is to plug these values in. Let's start off with a blank slate here. And then I go y of 2 pi over 12 is equal to 4. And then I plug in cotangent. Theta is now 3 pi over 12. Or 2 pi over 12. Now in this case, it's going to be convenient for me to say 2 pi over 12 is pi over 6, right? Because I'll be subtracting pi over 6. And there, it's at 0. So I go 4 cotangent 0. And then I plug in the 5 pi over 12. Again, no, so I'm going to want to keep the 5 pi over 12, and I'm going to want to change the pi over 6 to 2 pi over 12, right? Just get a common denominator there, and then that's 4 cotangent. All right, and then what do I have here? I have 5 minus 2 is 3 pi over 12. And 3 pi over 12, that simplifies to pi over 4. Okay? All right, so there's the rest of those. And you can examine those if you need to and see what we did. And there's going to be some, be some work with the fractions here, right? So 8 pi minus 2 pi is 6 pi. So I have 6 pi over 12, which simplifies to pi over 2, right? And we get these, so these are the values of y, right? We want to be able to evaluate these without a calculator. So let's go ahead and isolate those. And then get a unit circle and find those values. So if I'm going to do the cotangent of 0, I'm going to be here on a unit circle, and my coordinates there are 1, 0. Cotangent is x over y. So the cotangent of theta is equal to x over y. So looking at that, these values here, if I put the x over the y, what do I get? I get 1 over 0, which is undefined. So this is undefined because the cotangent of 0 is undefined. Then let's look at the pi over 4. So pi over 4 puts me here, and the coordinates of that point are rad 2 over 2, rad 2 over 2 on the unit circle. Of course, for all of these, r is equal to 1. And the cotangent is x over y. So when I look at the x coordinate over the y coordinate here, what do I get? I get 1. And then that is what this evaluates to. So the cotangent of pi over 4 is equal to 1, and 4 times 1 is 4. Pi over 2 puts us here, and the coordinates for that are 0, 1. And when I look at the x over the y here, I get 0 over 1, which is 0. Therefore, the cotangent of pi over 2 is 0, and 4 times 0 is 0. Here, the cotangent of 3 pi over 4, 3 pi over 4 puts us here, and the coordinates at that point are negative rad 2 over 2, positive rad 2 over 2, the x over the y in this case. So if I take the x coordinate over the y coordinate there, I get negative 1. So that means I'm going to have this is negative 1. Cotangent of 3 pi over 4 is negative 1 times 4 is negative 4. And finally, I'm here at, I miswrote this one here. All right, so this one here, that should be pi, okay? So maybe you caught that when if you were examining those before, but yeah, that's pi. Okay, so we'll put that there, and the cotangent of pi is going to be based upon the coordinates of negative 1, 0, and when I do the x over the y, again, that is undefined. Okay, so let's put those values in the table here. Undefined, 4, 0, negative 4, undefined. And then we'll look at graphing this. Whenever you're graphing, it's best to work with graph paper. And give myself an XY axis here. And it's also best to be free to do whatever scale you want. So when I assign these, or if I give a quiz on these, graph paper may be provided, and maybe even a scale is provided. And sometimes that scale is inconvenient. And you know what? We should just throw that out. Just cross it out and start fresh so that we can do our own scale, a scale that would be convenient. So what's the scale that's going to be convenient here? It looks like I'm going to want to know where the twelfths are, right? Do I want to do pi over 12? So if I do a scale of pi over 12, well, I mean, I don't think I'm gonna have as much space as I would like, because I need to get up to 14 pi over 12. So I would need 14 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 there. So that's going to pull me like somewhere out here. And I need to do two cycles. So that doesn't seem like the scale that I would want to use and be able to fit two cycles of this on here. So this can require a little bit of thought sometimes. It seems that to get myself more space here where I can get two cycles, I'm going to want to go to a larger scale for each mark, right? So pi over 6, let's just make it twice as big and call this pi over 6. All right. Then I've got every one of these, or in the middle of these is the pi over 12, right? Is the amount of pi over 12. So let's see if we can graph it. That way, scale here, I don't like that my x-axis is a little bit off of the grid here. Let me get it more precise on the grid here, so that we're a little bit more accurate. So that's a little better. Still straying off there. Okay, so there's pi over 6, and then let's go 1, 2, 3, 4. 1, 2, 3. And I don't have to make all of these marks, but I don't know why I did so. But we'll go like that. 1, and now let's graph the points that we have. So pi over 12, or 2 pi over 12, is pi over 6. And that's sitting right there, right? So that's undefined, and that means vertical asymptote. And then the next one here, 5 pi over 12. So that's going to be, just watch here, so it's going to be 2, 4, and then halfway is 5. So that's where 5 pi over 12 is, and then I want to put a point at 4. That's going to be right there. 8 pi over 12, so that's 2, 4, 6, 8 is there. That's 8 pi over 12. And then 11 pi over 12, I'm going to go 1.5 grid marks and then go down to -4. And then finally 14 pi over 12. So that's going to be 7 grid marks, right? Because that's 2, 4, 6, 8, 10, 12, 14. That's 14 pi over 12 there. And let's put a vertical asymptote there. Like that. All right, and then we should know the general shape of the cotangent. And it's just going to go through the points and approach the asymptotes, right? Just like that. And then we need to do another cycle. So I'm just going to go like this. See, I'm just going up 1.5 grid marks now. So 1.5 grid marks, and then 1.5 from there, and it's 0, and then up 1.5, -4, and then up 1.5, and get another asymptote. All right, now I do want to identify where this is at. okay? And I just counted off, huh? So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's at 13 pi over 6. So I do want to know that. 13 pi over 6. And another way that I could have done that is by adding the period, right? So I could have gone pi over 6 plus pi, and that'll take me to 7 pi over 6, and then plus pi would take me to 13 pi over 6, because we have two periods, right? And I know that the period is equal to pi. And there we go. So the 5-point process, it's always going to set us up when we do cotangent with, we're going to have when we do our argument, we're going to have cotangent of 0, and then we're going to end up with cotangent of pi over 4, cotangent of pi over 2, cotangent of 3 pi over 4, and cotangent of pi. And that's what the initial point and the step do for us. When I use that initial point and I use that step, substituting for theta is going to yield these values. And then those values are convenient values that we can use the unit circle to evaluate. So that is the graph of cotangent.